Hello, Legacy Sabers, Marsh here. So today we're going to talk about lists, the ability to store a lot of data in one single quote unquote variable. Your essential question today, how can I hold more than one value in a variable? So right now we can make a variable using var my name and then something along those lines. Now remember we had this idea that it was a plastic bag and then that plastic bag was one unit of information represented on a sticky note. Block versus text. This stored a single value. But the thing is what if you have a lot of information and all of that information is related? So maybe like this pile of numbers right here is all test scores, right? Maybe this is all the days of the month or days of the week. We have information that is a lot of it and it's all relatable. Introducing a list. Lists are just an ordered collection of elements. So we're going to imagine them as a gallon bag. Inside that bag are smaller connected bags. So each smaller bag can hold one value because they're each kind of like their own little variable. And then the gallon bag is named as the same rules as the variables. We can't have spaces, can't start with a number. And to reference each of the smaller little bags inside, we're going to refer them as a number starting at the number 0. So right here, I have a list. It's called lunch food. And inside of lunch food, I have the following elements. I have nachos, pizza, and soup. Soup, we would say, is in spot 2 of our list. So our list, like I said, is made up of elements or basically pieces of data. So each of these would be a piece of data inside of our books list. Each element has its own index. That index is just a number attached to each element. It's so that we can refer to one piece of data of the list. Indices start counting at 0. That is something that is kind of an abnormal. We're not really used to starting at 0, but computer science lists normally start counting at 0. The length of the list is how many elements the list contains. So in this case, our list books has 3 elements, 1, 2, 3, but its last index is 2 starting at 0. That is because of the 0. That's why it's not 3 for the last index. So right here, this is how I make an list or make a list in JavaScript. So var my list equals, and then I have these square brackets. These square brackets show how to make that I'm making a list. And in this list, I'm putting pizza for one element and 4 for another element. Something that's cool about JavaScript is not everything in the list has to be the same data type. Not all languages allow that. So in here, pizza would be an index 0 and 4 would be an index 1. If you are using drag and drop, then you would drag in the one that has the square bracket stuff. These little arrows allow you to increase the number of elements or decrease the number of elements, depending on which one you want. In here, also, you could just put a comma right here and you just keep typing and it'll actually put the spots for you. So right here, if I want to refer or access a particular value at a particular index in the list, I use the name of my list and then square bracket, what index am I interested in using? So in this case, if I said my list 1, so if let's say my list is lunch food, I would be accessing the first index, which is the second element. It would be pizza. So I could console.log that, I could set text of something, I could do whatever I want with that lunch food bracket 1. Now, just like variables, you can use these lists, list access to copy a value and then evaluate an expression. So if I say 3 plus my number's 1, what that's going to do is it's going to access the number that's in spot 1, index 1 of my list, which in this case is 20. So that 20 is going to go down there, and then I would get 3 plus 20 obviously is 23, right? My number is 0, that is the spot 0, so that would be a 10. And then my number's 2, that is 25. And 10 plus 25 obviously evaluates to 35. So when you are using a particular accessing from a list, all you need to do is just the name of your list, square bracket, what index are you wanting to access. Now be careful, if I would have said my numbers bracket 3, I would get an index out of bounds problem because there does not exist an index 3. Now, sometimes you want to directly assign a particular index inside of a list and maybe change the value. To do that, you're going to say the name of your list, so my list, bracket what index do you want to change and what do you want to assign it to be. So what this allows you to do is it's going to change a value inside that. Now this index does need to exist inside the list. You can't just change a index like 1,000 when there's not that many spots. Just like a variable assignment, the old value is thrown away and you are replacing. So far my numbers 10, 20, 25. So that means in my numbers I have a 10, a 20, and a 25 in spot 0, 1, and 2. In spot 0, I'm going to assign it a 5. So that means spot 0 is now 5, just like you see there. My numbers bracket 2, so spot 2, index 2, I'm going to put 30. So instead of being 25 here at index 2, I'm going to have a 30 there instead. So go ahead, run this program. What I'm going to ask you to do is pause the video here and go ahead and see, can you figure out the answer to this program? Okay. So spot 1 is cat. So I'm going to first change the indices. I'm going to write the little index below. 0, 1, 2, 3. Spot 1 is now cat. So hat is now cat. Spot 1 is cat. So in index 2, I'm going to put cat. So we're no longer POW. We are now cat. Spot 0 is assigned what spot 3 is. Spot 3 is a 5. 5 plus 10 is 15. So spot 0 is assigned a 15. So that means it's no longer a 20. It's now a 15. Spot 3 is whatever spot 0 is, which is 15. Spot 0 is a 15. 15 plus 15 is 30. So spot 3 is a 30. So my stuff's values are 15, cat, 30 for that. Kind of confusing, but kind of fun at the same time trying to figure it all out. This one, we can use expressions in the place of the list index. Like right here, you have 2 minus 1. Why would you do that? I'm going to be honest, pure academic purposes right there. But what that is doing is in spot 1, because 2 minus 1 is 1, I'm going to put tree. So instead of being cat, I'm going to put tree. Because remember, spot 0 is a dog. Now, this one's kind of different. My stuff bracket 2. So that is the value of my stuff at index 2, which would be 0, 1, 2. So spot 3. So my stuff bracket 3 is going to be whatever's in spot 0. Well, in spot 0 is the word dog. So in spot 3, I'm putting the word dog. So 0, 1, 2, 3. I'm going to put dog there. So I'll get an answer of dog, tree, 3, dog for my answer. Let's pick an outfit. So we're going to go to number 1. You're going to go to classroom. You're going to click on the code.org link under today, and you should get to level 1 in that case. We're going to run this program quick. Looks like I can, whoops. Start here. So let's run this program quick. I'm going to click run. It looks like I can choose a top to wear, and it looks like I can choose a particular pair of pants or shorts or skirt to wear. So let's look at this program here. So first thing, I have 2 lists, one called tops list, obviously, and then one called bottoms list. These must store Right now, they're not storing anything, but I'm going to guess they're going to store probably the shirts and the pants, right? Then there's an index for the tops and an index for the bottoms. Right now it's assigned 0. We'll go look and see what that means here as we keep going. We have a function called fill lists. We also have a function called update screen. Let's go read those. So fill lists, well, it fills the list, right? Puts things inside of tops list, things inside of bottoms list. Update screen finds us the current top that we are wearing. So tops list 0. So it makes the first top be 0 if that's the start of our program. It makes the first bottom be 0, and then it assigns those images. So in our tops list, the yellow hoodie must be the first one, and in the bottoms list, it must be these blue jeans. We have these on events for buttons. So right here, I have the left top button. That is, oops. Marsh accidentally clicked a button. There we go. That is this button right here. So if I click the left button, here's what it should do. It first needs to check if the tops index is greater than 0. And if it is, it's going to subtract 1 from the tops list. Now let's think about what this means. So that means if I click to the left, if I want to go to the next thing on the left, I need to subtract 1 from the index, right? Because if right now I'm in spot 0 of my list, but if I go to spot 1, which is this top, if I click here, I want to say go to the left. So if I'm in spot 1, that would be spot 0. Now, the if statement is to protect me from going to a negative index because that doesn't work. I can't go to a -1 index because there's not a -1 index. So I have to make sure that the tops index is greater than 0. If it'd be equal to 0, that would not work either because I would subtract 1. Same thing for the right top button. If I click to the right, that means I have to add 1 to our index. But the thing is I have to make sure that there's something on the right to go to. So this if statement right here is checking for that. It is saying, is tops index less than tops list.length minus 1? Now you're probably looking at this tops list.length minus 1 and going, whoa, what does that mean? Well, let's think through this. Let's see what's the length of my tops, right? How many top shirt options do I have? I have 1, 2, 3, 4, 5, 6. 6 different tops available. So 6 minus 1 would be 5. Now, if I go into my watchers area, I think they have, yes. So my tops index right now is 5. So think about it. If I tried to add 1 to my tops index, I would be out of bounds, right? Because I can't have 6. Because even though my length is 6, that means the last index is 5. So whenever you see tops list or name of a list dot length minus 1, you can read that as last index. So they are checking to see, is the index I'm currently on less than the last index? And if it is, then I'm like, okay, perfect. Let's add 1 to it because I can go further to the right. Same thing is happening for the bottoms and for left and right. Now they want us to change it so that when I press the right button, is set to 0 if the user hits the right button when they're ready at the end of the list. So if I click right here, they want it to go back to the hoodie. So we're going to look at this one. So what we're going to do actually is we're going to add to our else. We're going to add an else. So if the tops index is less than tops length, that's okay, right? I'm okay with that. But if I am at the last index, that means the next one would be all the way on the end, right? The left side. So I'm going to assign tops index to be 0. Now, if I run it, if I get to the last shirt, do you see how I go back to the hoodie? I get infinite forward motion. Now, here's the weird part, can't go to the left. So let's fix that too. I know they don't say that we need to fix that, but let's fix that. So I'm going to go to the left top button. If I am all the way on the left, right? So I'm at the 0th index. I would want to go all the way to the back, right? To make myself do an infinite turn on the left as well. So in that case, what I'm going to do is I'm going to assign top's index and I'm going to make it the last possible index. Now remember the code for the last possible index. Well, you're going to say, well, it's 5, right? That's the last index. But what if I add more shirts? Then that 5 will be hard coded and it won't be the last index. So to hard code, to use the fancy code to get our last index, we're going to use our tops list. We're going to say the length of it, but we got to subtract 1 because that gives you the last index. So now if I run my program and I click to the left, I now can forever click to the left and forever click to the right. Now I want you to pause the video and I want you to do the same thing with the bottoms, okay? Make it so the left goes forever to the left, make sure the right goes forever to the right. Very similar code, you're just using a couple of different variables and a couple of different lists. Okay, here's what you should have done. On the left button in your else, you should have made the bottoms index be equal to the bottoms list dot length minus 1. And then for the right button, you should have made the bottoms index be equal to 0. So now, forever to the left and forever to the right. So ultimately, the ability to change a current element is very important, especially in code.org, being that we're using a UI element. If you press the left button, you want to go to the left, meaning I have to subtract from my current index. If you're already at the furthest left index, we do need to not move forward, right? We can't move to the left. If I press the right button, I want to go to the right, which means I have to add the current index. If you're already at the furthest right index, list.length minus 1, you don't want to go any farther, or you want to go back to 0. These two things of code, these are under your important code to know area. These two things are quite important and they show up quite a bit in our programs. The ability to check to see, am I able to go to the left and am I able to go to the right? Notice these ones do not have that optional else that we just wrote. If you think that that is a cooler way to do your program, feel free to add that into your notes. However, most of the time we just want to make sure that we don't go out of bounds on the left or the right. The next one, we want to make a band name. So on your code.org, go ahead and click finish and go to puzzle number 2 for me. So puzzle number 2 here, I'm going to run the program first. Sideways porcupines, kind of okay. The Whoopsie Puppies, that's a pretty good band name. Let's go take a look at this actual program, right? So in here, we have an adjective list, so a bunch of adjectives. We have a noun list, so a bunch of nouns. They made adjective index be 0, noun index be 0, and then we have an update screen function. So the update screen, we pick a current adjective, we pick a current noun, and then we make the band name and assign it. If I click the randomize button, notice what it's doing. It's creating a brand new noun index, and it's picking a random number from 0, noun list.length minus 1. Now you're probably thinking, well, Marsh, okay, hold up, what is that doing? Noun list.length minus 1, remember that is code for last index. So it's saying the last index of noun list.length. So last index of noun list. Which in this case, if we go up here, that is 1, 2, 3, 4, 5, 6, 7. Okay, so from 0 to 6, I'm picking a random index because remember the seventh guy has an index of 6. Adjective list, I'm doing the same thing, 0, comma, the adjective list dot length minus 1, and then I play the cool little noise in our program. Now, if I add an index, what's nice, or add an element, I don't have to worry about changing this. If I had these hard coded, so if I put a 6 right here, a noun list, then it would work just like this program. But if I added something, we would never get that last noun. So right now, if I add here and I put, I don't know, pencils, I still, using my program, did I not finish my program? Oh, that's me. Didn't put a quotation. There we go. Trying to get pencils here. I had pencils. So even though I changed the length of my list, I still am allowed to get that random value, which is kind of nice in our program. This ability to get a random element of a list is very important. It's very useful. Sometimes you need to pick a random valid index, and especially valid is the word there, because I can't just pick a random number because it needs to be within the number of index values that I have. So what you're always going to do is you're going to use that random number function that's in JavaScript. You're going to start with 0 because that's the first index that we have available. And remember right here, this is code for last index. Okay? Now, what if you want to change your list? What if you want to put things in or remove things or do something like that? First thing is the remove item. I know, I read your mind. List, comma, index are the two things you need to provide. So you need to provide what list and what index do you want to kick out. This removes the element in the given list at the index that you asked for. All items that are on the right, they're going to shift down to fill the hole in. So if I remove index 1 and there's people to the right of it, there will be a new value at index 1. You don't just get a gaping hole there. You do have to have an index in the middle of the other indices. So right here, I have an array called my numbers, 10, 20, 25. I removed whoever is in spot 1 or index 1. So that means the 20 got kicked out. Do you notice the 25 kind of scooted down and became the new spot 1 because he has to move down. If I remove index 0, so that means 10 is going to kick off, but 25 needs to scoot down. He becomes the new index 0 now. Next possible thing you can do with a list is you can append an item. Append item, you're going to provide what list and what item. Now, append item adds a new element to the end of the list. You're going to be like, Marsh, how am I ever going to remember that? Here's how I remember it. You see how those P's, if you turned them around, they'd become D's. Then it'd be add, end. That's how I remember that append adds to the end because it literally looks like add, end. A new index is created and you put that element in the spot. So think of it, append item, as like adding a bead to a bracelet or a necklace. So right now I have my numbers. He has a value, only one element of 10. And I said append item my numbers 50. So notice 50 has been put onto the end of my list. A new index 1 was made. Now again, my numbers, I'm going to add a 100. So that means 100 is going to be put on the end. I'm going to add a new index there. Now you're probably thinking, well, Marsh, what if I want to add in the middle? Here you go. Insert item. Insert item allows you to add in the middle of a particular list. So you're going to say what list, what index, and what item do you want to put in there? So this is going to insert an item in a list at the index that you gave. That new index is added to the list, so there's space for the new element. And the new element is placed at the index given. All others items will move to the right. So if I add someone in spot 1 and there's people in spot 2 and 3, everybody will scoot down 1 to make room. So right here, I have a variable or my list called nums 10 and 50, nums 1 comma 20. So what I'm doing is in spot 1, I put a 20. Notice 50 slipped down to make room for that 20. Again, into nums, I'm putting in spot 1, a 100. So that means there's going to be a 100 be put in there. And then 20 and 50 are going to scoot down like no room around the Alice in Wonderland tea table. So here's what I want you to do. I want you to run this program. Pause the video here. See if you can figure out what the list, a list, has for a value. Okay, you should have tried it here. So append, remember add to the end. I'm going to add a 5 to the end, and then I added a 10 to the end. Remove item in spot 1. Now remember, that doesn't kick off 20. That's going to kick out hat. So that means there is pow now in spot 1. 5 and 10 are in 2 and 3. Just because I kick someone off doesn't mean the beads in my necklace don't slip down, right? Insert item, list, spot 2, I'm putting bang. So right here in spot 2, between pow and 5, I'm going to put a bang. That's in spot 2 now. 2 becomes a 3, and 3 becomes 4. So I now have in my list a 20, a pow, a bang, a 5, and a 10. Let's try another one. Again, pause the video, see if you can figure this one out. This one has a lot of things that you need to figure out together. Okay, so first, B list bracket 2, that is spot 2, which is po. Tay, and then P list spot 1 is toe. So I'm spelling the word potato. Haha, Marsh. Haha, we're adding potato. All right. So I'm going to add potato to my list. Then insert item in spot 1, go. So I'm going to put a go right there. And then I'm going to remove who's ever in spot 2. So 0, 1, 2, 5 is going to get kicked out. Po and potato are going to go scooting down. So I'm going to get to, go, po, potato. Sounds kind of like a chant in a way. Okay, let's make some pairs. So on code.org, you're going to want to click finish and go to spot number 3, please. Okay, close everything up. Let's run our program. So I have people, you, me, and another person. I'm going to add another person. We're going to add Bob. Bob's a nice person. Add. Okay, so I added Bob. Notice he adds at the top there. I'm going to remove me. Okay, and I'm going to make a random pair. You and Bob. What if I make another one? Oh, because I don't have enough people to make a pair. Okay, let's take a look at our program. So people list, we start with you, me, and another person. That makes sense. Update screen. So update screen, set property, people label, text, people list dot join. I don't know what dot join does. Let's go take a look. I'm going to go under variables and there's got to be somewhere in here. Right there. Okay, let's look at the example. Sometimes we want to put all the items in our list together. Dot join allows us to do this and choose what we want in between the items. Ooh, that's super useful. So what this is doing, I'm going to change this /n. I'm going to put an and. So what this is doing is it's taking the list of people list and putting a separator in between. So now that I've changed the /n, aka new line command, I put and. Now do you see how it says you and me and another person? So now if I go back to /n, you're adding a new line. Allows it so you don't have to type everything out. It just combines, takes the list and makes it nice to print out. And then it makes the options inside my dropdown be the people list, which makes sense. If I add a person, we get the text from the input. So right here, we insert the item in spot 0, like I noticed Bob was added. And then it makes this input box go to blank. Then it updates the screen because we need to update Bob and put him in the list. If I remove the person, I get the index of my drop down, ooh, I get the index, what spot I picked, and I remove that particular index. Interesting. Then I update the screen. Now, random assign. If people list.length is greater than or equal to 2, why do I have to worry about that? I have to make sure the length is 2. Otherwise, I can't make a pair, right? If I only had one person in my list, I can't make a pair. That makes sense. So it looks like I'm picking a random index. Remember, people list.length minus 1, that's code for last index. And then I pick that random person. So this is just picking a random number from the list. This is then picking the random person. I then remove that particular person. Sounds odd. We'll take a look at that in here in a minute. I then pick another random index. So I pick a random number again. I then pick the person that's at that random spot. And then I remove that person from my list. I then combine the text together of those two random people's names and print it out. This remove item, don't follow me off this cliff. I'm going to get rid of it. I don't know why it's there, so I'm going to run it. I'm going to assign a random pair. That makes sense. Notice what happened here. I have now picked myself twice. I picked me twice. My random index was me twice. I'm going to put that. Come back, remove item. I have to remove me. Okay, that's what I picked first, right? So that I can't pick it again. Otherwise, I would have had to write an if statement that says, if the random index 1 is equal to random index 2, that would take forever. So just kicking out the guy that I pulled in first, I can remove that spot, and then I don't have to worry about finding the same thing twice. Let's go see what they want us to update. They want our default names to change. So we're going to do, let's do Bob, Alice, and Steve. Good names for people. Okay, Bob, Alice, and Steve are now my people. And we're going to update this group to pick groups of 3, not 2. So that means I'm going to change my list length to be 3 because I need 3 people, right, to make this program work. I'm literally going to do almost the exact same thing, but I'm going to walk myself through it. So first thing I need to do is I need to pick a random valid index. So I'm going to pick a random index, the third one. And I'm going to make a random number. So I'm going to go through my math. Random number. The first index that I want to possibly pick is 0. The last index, remember, our code word, people list.length, -1. That is the code, secret agent code for last index. So that's going to give me a valid random index. I now need to pick a valid name that corresponds to that index. So again, I'm going to make a brand new variable. I'm going to make it named random person 3. And I'm going to, from my people list, grab the name that is in index random index 3. And then to make sure that I note that I use that person, I'm going to remove the person at the random index that I picked. Notice I can't say random person 3 there because I have to provide an index, not a element. So now if I run it, I should probably make sure I add them to the printout, right? Silly, silly Marsh. Okay. Otherwise, I'm making a group of 3, but I'm not actually printing that out. There we go. Bob, Steve, and Alice. All 3 together in a trio of people. So sometimes you don't want to fill an array because it's way too much work. Code.org has a data lab that allows you to take in data from what's called a data table. Var list equals get column table, comma, column. Now, ultimately, If you go onto your core.org one more time and you click finish and we go to number 4, they've already uploaded the cats data section. We're going to go into the data area. So if you click data, notice what is on here. So there is a lot of data sets. For example, culture and entertainment. They have the best-selling video games. They have Grammy winners, esports earnings, various information. This is mostly updated too. It'll tell you kind of information about that. If I click into cats, they give you what's the name of the cat, minimum lifespan, minimum weight, maximum weight, temperament, a whole bunch more information there. Origin. So I can pull any of these columns. What's kind of cool is you could pull, so this is giving the column of names. So if I run it, I now have all the names of all the cat types. This allows you to be able to import various bits and pieces. And you can make multiple lists that you then could look through and identify, because spot 0 in the names list would be also the same spot 0 in, let's say, the minimum lifespan. So then if you pull the name and the minimum lifespan in spot 0, you would have corresponding data. Kind of neat, allows you to not have to make a bunch of information inside of your array. Now, some key takeaways. A list is just an ordered collection of elements. Sometimes you'll hear me call it an array. Some languages call it an array. That's why my brain kind of uses those two words interchangeably. An element is just an individual value in that list, and it's assigned a unique index. The index is just a common method for referencing the thing is string using some numbers. Remember that index, the first index is 0. Oop. My pen does not want to work today any longer. So that would be a spot 0. Let's see. Can I make it work now? Oh, nope. So spot 0, spot 1, spot 2. I just lost my ability to find my thing. There we go. We'll do a laser pointer. There we go. So spot 0, spot 1, spot 2. The length of list is how many elements you contain. You can grow and shrink. And list.length -1 will give you that last index. Lists are an example of a data abstraction. This is an important word. This word pops up quite a bit in our CS principles study. This allows us to name a program with large collections of data, but we don't have to know about how it's being stored. They're easier to maintain, easier to develop. This is the same idea. We also have that function, which is also an abstraction, because all you get to do is call the function. You don't need to know how it does its job. You just need to know what it does. Same idea here. We can take a lot of information and shove it into one value. We don't need to know how it's stored. We just need to know what's stored in it. And that is the end of this video. I know, super long video. Sorry about that, but there's so much information to talk about with lists. I hope you enjoyed learning more about them, and I look forward to continue working with you and helping you guys understand lists further. I will see you later, Sabers.